Okay, thanks. Hi, yep, that's me. And as Leon was saying, oh, yes, lights, okay. So it's really just a little slideshow. Feel free to ask me questions or stop during it, might be better, or we can go back. So I just sort of started here. This is probably the first work I made using new technologies, this is back in 2002, I think, off the top of my head. So it's a skull, and it's actually based off a famous painting, which I'm sure some of you will know. I'm going to show the painting in a little bit. And I've used Rhino here. I'm sure some of you guys use Rhino. And I pretty much distorted the skull, then ran a contour through it, and then laid it out in Illustrator to CNC cut high impact styrene hips, which was pretty crazy because there's about 1,000 parts there. And then I had to figure out how to put it back together, which was, I had to build maps, and I ended up building registration holes and all sorts of things to reassemble. So that was sort of my starting point, and that started off at a master's degree that I did at COFA in new technologies for sculpture. So just jumping forward here, now I've always been using, or always been fascinated by 3D printers for sculpture, and you can see that I use a lot of different types of 3D printing technology. And back in 2009, because I was very aware of what was happening, particularly with open source, in 2009 I built my first open source 3D printer, which is from the RepRap guys, from a professor out of London. And as far as I know, I might have been the first person that built the first open source machine in Australia. No one's refuted me yet, but I'm happy for anyone to get up and say, but 2009, there it is. So you can just see it's not that dissimilar from your replicators downstairs. It's just that it doesn't have any of the bits covering it in the housing. You know, it's actually made of threaded bolt and bits like that. Now, I guess a lot of the things that because I work with data to produce the works, I'm always hungry for data. So this is actually a project that I was doing at the Institute of Sport down in Canberra. They have a full body laser scanner. And these are just some of the scans that I took. And I'm actually moving inside the scanner. So that's why the data's quite distorted. And I've made a couple of sculptures with this type of technique. Although I have to say, being a bit of a data snob, I'm not very happy with the quality of the data that you get out of that type of scanner. And that's just after having to fix it, like fixing data in software is a pain. Anyway, there's one of the sculptures there. You can see that that's one, is this one here, up there. So what's happening here is these 4 lasers come down, and they're coming down, and you can actually move during the scan because the scan takes 12 seconds or thereabouts. So in here, I'm actually sort of moving and reaching. So I'm keeping my body stable, but my arm is moving after, and I can just see the laser going down. So I'm sort of subverting this process of capturing data. And with laser scanning, I've been laser scanning or mapping myself for years. I first started doing that in 2003. I did a full body laser scan, naked. You know, it's not art if you're not naked. Anyway, there's a funny story about that because the guys that I was working with, I mean, these guys were geeks. You'd ring them up, and if you got the answering machine, it was the voice of Spock telling you there weren't any sentient life forms here at the present time. You know, you go there and they'd say, you want to look under the hood? And they meant the computer. You know, this super cooled computer that was doing all these silly processes. Anyway, so I stood there for doing a laser scan like this, like a sprite, okay? And that's so that later I could rig my own digital body so I could manipulate it into different poses and then 3D print it. Now the funny thing was, you know, I was obviously really keen to get started, get to work, and they kept saying that they were sort of going, oh, we've got a bit of a problem with the data. And I'm like, what do you mean? And they said, well, you moved. And I went, no, I didn't. I didn't move. I went, well, we can't put your penis back together. So what had happened was they started scanning here, and then they went around that way, and it was winter. And so it was a bit cold, and they just couldn't, everything else they could put back together, but apparently that bit moves a lot now that I've done this process. And so there was this very funny bunch of emails where they were modelling me a digital penis and putting it onto my real digital body. And so this process went on for a bit till the end. I was like, okay, that's it. I'm coming in, I'm going to drop my pants. We just scan it, we put it on. I don't want any sort of strange digital penis on my digital body. Anyway, things we do for art. Okay, so this one's another scan of me, and this is using booleans. And I'm a bit of a fan of booleans inside software, and I probably couldn't say enough about George Boole, who wrote Boolean mathematics in about 1857, around then. Anyway, he probably was publishing papers. He would never know what a huge effect his branch of mathematics is actually having on our lives today and the work we can do. So Booleans underpin a lot of software that you use. You know, if you're searching, you can even do Boolean searches. If you're working in 2D or 3D, you're often using Boolean functions. So I'll probably end up doing a lot more work with Booleans. This is also a scan from that same time at the Institute of Sport, where I was really looking at trying to make a fourth dimensional sculpture. So we see ourselves from one moment, but you only see me at this moment. What if you saw me at several moments, all simultaneously at once? And you can use Booleans, by the way, to put the data together. So this is what this is. This is scanning a dancer inside of a laser. Although, again, being a bit of a data snob, it's not great data. So I actually got to this stage and then I dropped the project. Mainly because I just know the problems with the 3D printing and all the rest of it that'll go on with that. This is sort of backtracking, and it's sort of a refinement of that first work we started with, which was the skull that I'd cut. So now we're at 2005, and I'm really looking at all the different 3D printing technologies. So this is printed in a wax printer. It was actually a Z-Corp one, printed in half and hollowed out so that it follows the rules of metal casting. I actually teach metal casting at COFA, so I'm able to print. I just understand how to print things for bronze casting. And I thought I'd include the famous painting. So if you wanted to, you could come up and see this painting. This painting hangs in the London Portrait Gallery, I think. Is that right? Anyone? Anyway, if you look at this painting here, the skull here corrects itself if you're looking from this angle. And I think the story is that the painting was painted and hung up the top of a set of stairs. So as you walked up the stairs, you saw the skull. So very, very much probably in the tradition of vanitas in painting. And then you saw the ambassadors. My work's called The Ambassador's Skull. Yeah, so moving on to this work, so it's another anamorphically distorted work, which is essentially taking a two-dimensional distortion and forcing it into a three-dimensional object. Now, I guess I put this one in because this was built on my printers. So the printer that I built I was able to program it enough and figure out how to print this work out in sections. So it was the first time I was sort of building quite a large sculpture in parts. And it's printed in ABS, and the sculpture is the print. And there's just another little close-up. I think this was on the flyer. So this is a larger work. We'll see some other shots of this one. Again, using booleans, it was sort of taking that idea a bit further and refining how I finished it and just casting it in bronze, which is quite a serious thing to do. I don't know if anyone's had any experience of casting in bronze, but this work stands about this high and weighs 80 kilos, okay? There's some other shots. I'll show you some work in progress shots. So something like this actually takes 3 months to build. You don't just wake up one day and go, oh, cool, gonna make a bronze. So there's actually work in progress. There's the 3D printed sections. So I printed it out, made the prints, molded the prints, then made the wax, like a traditional lost wax. And I guess this whole idea of this sort of work is about I see all of us, we're at this moment in history where we're digitising ourselves into cyberspaces, whether you've got Facebook or something like that. We're investing and mapping ourselves into computers. So if we're doing that, we're now subject to the rules of that space, and this character is sort of being deleted by the possibilities of computer spaces and cyberspaces. And that recurring theme is throughout all my work. So this guy here is manipulated using sine wave. So it's mathematical things. And what I'm trying to suggest is that something of this world is now starting to affect our world. So this organic world. And that's another point that I make, is that all my data is always taken from life. I always scan the organic world. Hey, Victor. And then I manipulate the organic data. Okay? So that's sort of in a nutshell where I'm at. This is me winning a big award. I dressed up like the sculpture just for fun. This is the this is the Mount Buller Sculpture Award. So this one's all about eyesight and voyeurism. So it's called the voyeur. And you can see that it actually is at a 45-degree angle. But if you stood in front of it, you can see it's actually normal human height. So it's designed, even though it's installed on a mound there, it was never meant to be installed on a mound, it's just the way they installed it the first time. It's designed so that you can stand next to it and you're exactly the same height and it looks completely normal. But as soon as you start to move around, you realise it's actually at 45 degrees. So I've corrected for the parallax error of eyesight, and I just used a computer to help me work that out. And there's a little marquette, so you can sort of see the example there. So the head is actually from, even though it looks bigger here, in actual fact the head is quite small in relationship to the feet, because it's forward in perspective, yeah? Here's another work. This work was first exhibited at this is called Whatever. This work was first exhibited in 2012 at the Wynne Prize, part of the Archibald and all of that. So you may have seen it, not sure. And this is the first time I really started looking at sine waves with data. And I thought, because you guys probably all use 3D printers, I'd show a work in progress shot. So you can see that there's all the layers. This is about 800 hours of 3D printing, okay? Because, you know, as soon as you get to a certain scale, and I'm sure you guys know, all the people that use 3D printers, they're slow, okay? So my way around slow 3D printers is just to have lots of them. And I just chop the files up and I'm printing on several printers. I'm actually printing on 2 printers right now. So I'm always printing, just because I'm doing some ridiculously large project right now. Here's another work in progress shot. So you can start to see how I've finished the 3D print. So all the lines that you probably see in those thermal plastic printers, I've filled in, just using like car finishing products, putties and spray putties and stuff like that. There's some shots of it. This work's quite unusual, and a lot of the things about using different mathematical algorithms, particularly a sine wave, is a sine wave is actually a second dimensional piece of maths. So when it's forced into a 3-dimensional object, you are going to have a tussle between these different dimensions. And you can sort of feel that when you look at this work here. Like if you get at certain points, it can actually look quite normal. So I didn't want to bring a big work in, but you can sort of get that feeling that, what am I looking at? Why is it? So there's a bit of a fight here, because we're always so used to looking at people, and people look a certain way. They shouldn't look sort of wobbly. So you really, in a lot of ways, seeing an image of a work like this just destroys the magic, because an image is 2D, whereas an object is always going to be 3D. So you actually need to be present in the room with it. This is, this body of work, these are called wall works, again, are all from laser scans of real people. And here I'm just trying to toy with the possibility of horizontal and vertical. I'm trying to make this work a little bit more subtle, in that you can believe it. It's that sort of suspension of disbelief, but the character actually stands on the wall. So you can actually sort of believe how the feet work on the wall, and then it's twisting between the vertical to the horizontal, or the horizontal to the vertical. Whoops, sorry about that.
So it's suspended on a vertical surface?
Yeah, it just clicks into the wall.
And is it solid bronze?
No, it's made to look like metal. It's actually really light. It's made using a rotothane and rotational resin and stuff like that. And it's got metal armatures, and I had to design a special keyhole plate in steel that I laser cut and put in the feet. It took me a long time actually to technically work that little guy out. And this is me working in data with, so you can see that I quite like getting compositions of people and then distorting them in a particular way. And the weird thing about some of this stuff is I have to do functions in a procedural manner. I don't know how much people work in computers here, but sometimes working procedurally is restrictive, and That's just one of the ways that you can't just be very free-flowing, or else you cause yourself problems. I sort of got to get in front of a computer to point that out, or inside software. Anyway, so these two guys are sort of in the same world together. So sometimes it's quite nice when I try to make a grouping of these wall work guys. And here's another one. I just had an exhibition recently as part of the Powerhouse Museum and Design Week. Unfortunately, it's down. Came down on yesterday. But there were quite a few of these wall works there. There's another one. There's another one. And you can see that this bit of data is the exact same character as this guy. Okay, so sometimes, because we're talking about data and I actually buy data from all around the world, or I scan data, I license it, okay, for different uses. So this guy here, I'm actually now turning him into a large sculpture that can exist on the ground rather than on the wall, because often in sculpture we always see it on the ground. Very rarely do you see it on the wall. So in a lot of shows that you apply to and things like that, they're always wanting sculpture that sits on the ground. I do email them and say, yeah, but mine goes on the wall. And they went, no, we want it to go on a plinth or something. And I'm like, well. So anyway, this is called the backwards attitude. It's sort of like a dance move, I guess. And I made one that goes on the ground. But still, I like to play with this sort of sense of impossibility. That's me working in software. And in actual fact, this bit of software is, I sort of split up the whole process in making a sculpture. Like, part of it would be the creative software, and then the other part's the pre-press for 3D printing. So that's another bit of software. And then, so this is my pre-press software, which is sort of simple, but it helps you to organise things really easily. So that's NetFab. I don't know if you guys use NetFab. And there's one version of this sculpture, but that's only life size. So I printed that out, and then I was like, oh, it was sort of a bit odd being life size. It was the first time I ever made something that was just life size, and it was a little bit disappointing. So I decided, oh well, let's go double life size. So this is work in progress. This I took about a week ago. So that head stands about that high at this stage. So this thing is going to be about 3,500 hours of 3D printing, which is sort of a bit silly. I probably should have just milled it. Probably would have finished the milling in a day. But I guess I own all the printers and I have all the material, and so.
Louis,
yeah.
When you have to do them through multiple printers, do you actually make a whole lot of separate pieces and join them together, or do you move the object around?
Yep. So in this software here, I chop up the data and prepare it for 3D printing. And one of the things that speeds my process up is that I don't print with support material, and I only print a shell. So there's no internal printing. So in actual fact, if someone else wanted to print this, it'd probably blow out to 10,000 hours plus. And in actual fact, just training in sculpture and learning to make moulds and concepts of undercuts helps me 3D print and print things so that I'm just printing things that I know will work in a 3D printer without collapsing.
So you can join the materials are such that they can be joined.
Yep. You can see all the joins here, a bit rough. It looks a bit like Frankenstein. So yeah, he's all cut up into different pieces and then joined together. So I just skin the material because the print is actually quite weak until I coat the inside with resin and then I pour in an expandable foam that's really rigid, and then you can just drill it all together and assemble something quite quickly that's quite large. Actually, that's how I did the Mount Buller work too. This is this guy in software. So you can see, and here we're using a particular type of scanning, and I think this is actually where scanning is going to go because, well, it's really quite useful and you get all the colour data. So this is actually a photographic dome of cameras that produces this type of data, and then it's a very bright lit area, and I think even this person is scanning themselves and holding the camera button to fire the camera. You can see in their hand there. And the cameras all take a photograph at the same time, big photodome, and then this software called Agisoft puts it all together. The problem with this, and why this hasn't been so popular, is that it takes a monstrous amount of processing power. So as computing power increases, I think we'll see that this will be the preferred method. We don't really have a decent rig in Australia at the moment, but there are rigs in other places. And I took a photo of that. Took a photo of this guy. So this guy, this is where I'm taking that colour data and peeling it off, and then I'm painting back into the colour data inside Photoshop and then rewrapping the character. So this is another little process where I'm adding my own elements and things to it. This is called Harlequin. And I thought I'd just show you the data. So when you unwrap something, the way computers work is they have to work in RAM squares. Well, it's better, they don't have to, but it's better if you do. So the texture map is actually a square shape. So that character back there was actually painted using this. So just to try and figure out how to paint backwards and forwards between these two surfaces it takes a little bit of playing to get it backwards and forwards. You normally have to wrap, unwrap, look where you're going, reposition things. Because you can see that I have actually positioned that's actually a cross on his chest and stuff like that. Actually, that's not the data, but there's no cross on there. Here's some other ones that I've been playing with. And this is a new project that I'm really looking at. I showed you earlier that project of scanning the dancer inside the laser. Well, I'm trying to now work with these photo rigs, and I want to scan a lot more movement and try and make these sculptures, or fourth dimensional sculptures of people, which would be something that fits into my practice as I look at other mathematical second dimensional distortions into 3D data. So it's sort of a natural progression for me to look at something that's playing with the fourth. And there's just that with a weird texture map that I was playing with. Anyway, that's the end of my little slideshow. So I'm open for question time.